With the idea of how we can determine the domain of a given function in mind, we're going to talk here about how we can stick functions together algebraically with things like addition, subtraction, multiplication, and division, which all work basically the same way they did for numbers, except because we've got x's to chase around, it's a little bit less clean. But anyway, if we have like something nice to work with, say f of x is 2x and g of x equals x minus 1, nice linear pieces, and talk about the addition of them, f plus g, you just add the two pieces up and you'd get 3x minus 1. If you want to talk about subtraction, you subtract them exactly the same way and you just get x plus 1. Multiply them, you'd have 2x times x minus 1, factor that out and you get 2x squared minus 2x. Divide them and you'd have 2x over x minus 1 if you do f over g. So it really works in exactly the way you'd expect, except that with that division case, you'd be a little bit careful about division by 0, where we have that the domain for a pair of functions like this, the domain for the combination, is going to end up being the domain for f intersected with the domain for g. It's just what's in both of them, with the potential caveat that if we have f over g or g over f, whichever we choose, you can't have a value that goes to 0 on the bottom, kind of like what we saw with our last example there, talking about the domain of the function 7x over x squared minus 25. But anyway, let's just get some quick examples here for how this works. So for f of x equals x cubed minus 4, and g of x equals 4x plus 5, we want to find f plus g, f times g, and f over g, describing the domains of each. So first thing we can notice is that because both of these are just transformations of nice polynomials, the first a cubic and the second a linear function, we know what their domains are going to be. We know their domains are fine. It's going to be everything. So we don't have to worry too much in the first couple of cases. We want to talk about f plus g of x. It's really nothing special. You just add these parts together. So you have x cubed, that should be plus 4, excuse me. I'm getting a little bit too positive, I guess. X cubed minus 4 plus 4x plus 5, or simplifying that down just a little bit, x cubed plus 4x plus 1. Where the domain here is going to be all real numbers because the domain of each is all real numbers. We end up with a polynomial whose domain is always going to be all real numbers. All is good. And multiplication works the same way. So we have fg is going to be x cubed minus 4 times 4x plus 5. And I'm going to skip the half step here of writing out all the foiling there because, well, that's actually where we end up with our answer anyway. There's actually no simplification to be needed. So actually, I'm not going to skip it. I'm just going to write it. We would end up with, in this case, 4x to the 4th power from the firsts. Then we would have 5x cubed from the outers. And then we have negative 16x from the inners, which I have to put in a funky notation because there's just not a lot of space. And then minus 20 for the lasts, as it were. So in both cases, as I mentioned, the domain is all real numbers, which I'm going to use that fancy notation for instead of the interval negative infinity to infinity. Remember, this means the same thing. In the last case, we're basically in the same way, well, just about in the same way, because there we have f over g of x. That ends up being x cubed minus 4 over 4x plus 5. And again, domain of this is everything, domain of that is everything, so we almost have everything, except we can't have that the bottom here is 0. Easy to find the solution for when that would be 0. That's going to happen when x is equal to negative 5/4. So the domain, if you want to be writing that in the interval, would be something like negative infinity to negative 5 over 4 union negative 5 over 4 to infinity. And there's also a nice way you can talk about removing a single element from there with a slash, but we're not going to worry about that too much. Point is, our domain's all real numbers except for negative 5/4, because that's when the denominator would be 0. Like I said, really very straightforward. We've actually worked with this sort of thing before. We just didn't, call it exactly this sort of thing. We call it something like this, a rational function, instead of like a division of two polynomials. And this sort of thing, we just write it as that quartic and maybe factor it if we want to, instead of talking about it as a multiplication of polynomials. And that's not really a sum, that's just a cubic. But we can always recontextualize in that way if we want to. Anyway, from here, the last big thing we're going to get for this section is the idea of putting a function inside of another function and seeing what happens to the resulting pieces through a notation we refer to as composition.